Hello and welcome to this video on OOP, Object-Oriented Programming in Python. So this is part of the Python summary video series. So welcome, and we'll go into the code. So we'll start with I will assume that you know some basics within object-oriented programming already, perhaps from another language, or maybe you have some basics within Python already. But we'll start. We'll start now. So we create a class. And what is a class? Well, a class is in Python, it's you can see it as a blueprint. It's a blueprint for creating instances. So for example, you have a blueprint of a house, and then you can instantiate several houses, right, from this blueprint. So let's create a class. I'll call admission. So from this admission, we'll have some initializer, and this is something that will run when the class is an instance of the class is created. So when we instantiate from this class, the dunder init will run. So def dunder init. Self corresponds to the this keyword in many other languages, but it refers to the object itself. So school, program, name, and a set. So we'll have self.school equals school, self.program equals program, self.name equals name, self.asset equals asset. So now we have defined the class. It has one method, and this is a dunder method. Dunder is a special method which you get through doing __. So there's a few dunder methods in Python. So we create admission of, I'm gonna call this cool school, and we can say the program is AI, and we can say the name is, for example, name is, let's see. Name is, let's do me. Option, accept. Yeah, I got accepted to this program, this AI program. So we can say person 1 equals this, person 1, or student 1. Yeah, we can take student 1. Student 1. Student 1. So when I just run this one, we see the dunder wrapper, which I've kind of touched upon in earlier lecture. But this is the representation of this object. So it says it's created in its dunder main.admission at some kind of memory address, right? So let's check that memory address. So hex ID of student 1. Ah, okay. We see this memory address is the same as the one in the dunder wrapper. Cool. So if we want to have something from student 1, we can have student 1 dot program. So we get its attribute, which is AI here. We get the attribute of student 1. We can take the name of the student 1, Skopje. We can take student 1 dot asset, and it's true. And as I said before, when we do like this with comma here, we get a tuple here. So what if I do student 1 dot program? I change this program to, for example, data engineer. student1.program. We get data engineer. Okay, so I can actually change it on the fly. So we go into, we've been in memory addresses. We can create another student now. Student2 equals admission of Gore board. It can be called, let's see, we do it with keyword arguments. Name, Gore board, school, another cool school, another cool school. Yeah. School. Okay, like this. We have accept equals true, so we use keyword arguments here. We have, let's see, what do we have more? Name, school, admission. I think it was this, right? Ah, program, right. Program equals, we say Java. Student2. I want to check if they have the same memory address or not. So student1 or student2, ID of student2, hex of ID of student2. Is this equal to hex of ID of student1? No, they are not equal. And this is because they live in different memory addresses. So now we have, if we recap here, we have created a basic class. We have instantiated from our class. We have instantiated two instances or two objects from this class, student1 and student2. We have given it different attributes, and it has the attributes from we have self.school equals school, self.program equals program. Then it's these are the attributes of the instances. So let's move on to the done the wrapper method. So let's see, I'll create done the wrapper. All right, I need to write like this, backslash like this, done the wrapper. Let's see, then I will copy this admission code here. So this is a representation when we write out this, for example, when I do like this, student1, then I get this wrapper, right? However, I can choose what it should write out. So the wrapper, I want to return an f string of admission and parentheses. I want it to give self.school, self.program, comma, self.accept. Name also, right? Self.name. And note here that I can access these attributes using the self. So we send in self. So we send in this, the instance itself into this, as an argument to this done the wrapper method. And then I can use this self and access its attributes. That's why this works. So let's do it like this. Student1. I will copy student1. I'll copy this guy here and do it again. student 1, student 1. Now I get this wrapper here. We see that I get this admission, cool school, AI, Coction, true. Very cool. So this I can do print student also, print student 1. Then I get this wrapper. However, the wrapper however, when you're printing, you might not always get the same as the wrapper. And that depends if you have implemented done the string or not. So then I can show you done the string while I'm doing this. Def done the string self return I can write whatever I want. This is the student, for example. Or done the string, I could write I could write like this. Student self dot name admitted to program self dot program, for example. Then I do admission of, I can copy this one, copy student 1 again. Right, and run this one. Now you see the done the wrapper. This is the done the wrapper, right? If I want to have the string, I can do string of student 1. Then I get the done the string. I can do print of student 1. Then I also get the done the string. Oh, but without the quotes. So note that if I don't have the done the string implemented, then it will choose the done the wrapper. But if I have it, then print will choose the done the string. Moving on to encapsulation. So encapsulation is an important concept in OOP to hide information so that it only can be accessed within the class. And information hiding is used for data hiding, hiding internal state, and bundling information to organize code and hiding implementation from the user. So you don't want the user of your code to know exactly what's behind your code. You just want to show them some part. But however, in Python, all methods all attributes are actually public. So to solve this, or a solution of this in Python, is that you have a convention, and the convention is that you use an underscore before it. So for example, class patient under init, we have self name comma diagnosis. Self dot name equals name. Self dot underscore diagnosis equals diagnosis. So we can have patient 1 equals patient of your board. And this guy has migraine. So patient 1, okay, this is the dunder wrapper. So if I do patient 1 dot name, this is no such big deal. It's the same as before. We have a public attribute. We can have patient1.diagnosis. If you think like this, it won't work because we haven't defined any any diagnosis with this symbol. However, if we do it with the underscore, it will work because it's private by convention. Nothing hinders you from actually accessing this attribute. However, you should not access this attribute. So Python programmers should know that underscore before, like as prefix, is private by convention. However, there's another way of doing private by convention, and which actually has some name mangling. So we could do it like this. I copy this code. I do self._diagnosis, but with 2 underscores instead. And I run this one, or I could call it patient. Oh, it doesn't matter. I use patient1. Patient1._diagnosis. Oh, right. Now you think it works. It's private now. Well, not really, because you can do it like this. If you take and check into patient1 and you do .underdict, look what you get now. So patient1.__dict, then you get the attributes here. So you see the name wrangling. So it has changed so that it becomes underscore, your class name, and then concatenated it with __diagnosis. So you can still access your attribute with this. So patient1, you should not do this, but you can do it. Let's see, patient1, right, you don't do it like that because it's not a dictionary, but with dots. Right, we still get the migraine. So let's move on to property and documentation. So you normally don't want to expose, you want to expose as little attributes as possible without having to control over them. So in other programming languages, we use getters and setters as an interface to the class. So it's what you should access. And in Python, there's property which gives getter and setter interface for accessing attributes. But it also gives a cleaner syntax, and it can include error handling and other checks in setters. And you can make read-only property also. So let's get started with an example. Class student. We'll create a dunder init. Self, name, age, active. And we'll also give some type hinting to say what type of type is this. This is a string, this is an int, active is a bool, and it returns none. So we'll start with self._name equals name. So note that we have a private attribute right now. So through this, we'll create a property. Property def name self. This will return string. Return self._name. Okay, so if I create a student now, S1 equals student of your board. How old are you? 54. Did you get admitted? Active? Are you active? Yeah, you're active. True. S1 dot name. So this is similar to saying S1 So in other languages, maybe you have s1.getName, right? But in Python, you have .name instead. So then this property will be run. And this property will return the backing variable, which is a underscore, is a private variable, which is the backing variable. So, for example, if I do s1.name equals Anna, it doesn't work. Because this property name, it doesn't have a setter. It doesn't have a setter. We have only defined the getter here. So this is the getter. So I copy this one and I continue building it. So let's say we'll create a property with a getter and a setter. Self.age equals age. We get the property, the age. Self. This will return an int. Return self.age. Or this will return self._age. I'm sorry. And this is what I mean. But however, the _age is not defined yet. Well, how do we solve this? Well, at age.setter. So we will set the _age. So that age self, comma, value. It will return a int. Or actually it won't return anything. It will return none. So self._age equals value. As simple as that. So for example, I copy this student again. Student1, student1.age. Has no attribute age. Let's see, student. Add property age. It should have. Okay, so I've debugged and it should be outside of the class because it was indented. So let's start here. So s1.age is 54. Let's remove the string. So why do I want to do this? Well, and what happens when I run this? When I instantiate this object, I set in 54 into age, and then this one self.age equals 54. Then self.age will actually use this setter. And when it's using the setter, then all the code in the setter will run, which in this case only sets the value. But it seems to be, why do we do this? Well, this is useful when I want to have some error handling. So for example, if not is instance value, comma, number. So then I need to import this number class. From numbers import number. So if it's not an instance of a number, then I want to raise an exception. Raise a type error. Age must be either int or float, not type of value. So if I do like this, it works. However, if I do another student here, Bordeaux, let's see, this, it doesn't work. It's a type error. Age must be either int or float, not class string. Okay, cool. And I could add some more. I could add, let's see, some more tests. So if not 0, value 125, raise value error. Age must be between 1 and 124, not not value. Like this. So if I have, for example, I take S3, this, you are 154 years old. S3, yeah, value error. Age must be between 1 and 124, not 154. Great. So we have some validation code here. Let's copy this one. And we can do a wrapper also, but I want to show, for example, if we want to count our students, we can do like this, number students equals 0. And whenever we are doing the dunder init, we can do student dot number students plus equals 1. Because number students is a class variable. So this is defined before the dunder init. It means that whenever it's created, then this will increase by 1. So for example, I will do this guy here. I do 15, I'll do S4, S5, S6. Yeah, they can all be Chris. It doesn't matter here. And I will do S6 dot number students. And we see that we have 3. We have created 3 students in total. So this is a class variable. Also, what I've shown with properties before, I want to show a normal method as well. Usually we start with normal methods, but in this case, I started with properties. So this is my class. I'll also create another method. Def say hi self print self.name says hi. So if I do, I copy Chris again. S7 dot say hi. So you access it through the parentheses. So you access this method, and then you do the parentheses, and you can put in the input arguments here. And also I want to add some documentation to this class. So this is a doc string. Let's see, student class for representing students with name, age, active. I haven't implemented the active part here. So this is a doc string. You can have a doc string for each of the methods as well. Read only property. Can't set name. So we could do help of our student class. And when we say here, we can see the documentation. This was written in our doc string. Also name, this was written as well. What else do we want to document? Well, usually you have type hinting. So this returns none. Value should be a float or an int, or a kind of number as a value. We can have age, name, string. Yeah, these are type hinted already. Yes, so this concludes the object-oriented part 1. And in the next lecture, we'll go through polymorphism and inheritance. Yes, thank you. Bye.